Okay, so second solution. In the second example, an was n over 2n plus 1, all to the power of n. And this tells us that its absolute value is, well, it's positive, so it's just itself. So we want to take the nth root of this. That's just going to kill that power of n. So we're left with 2n plus 1 under n. So hence, L is equal to this limit of n over 2n plus 1. And we know how to take this limit. We divide top and bottom by n again. So we're left with 1 over 2 plus 1 over n, which equals a half. In particular, half is less than 1. So, hence, the series sum n equals 1 to infinity, n over 2 to the n plus 1 to the n converges. It converges absolutely, and it converges. But in this case, that's the same thing because all the terms are positive. This is by the root test. Okay, so exercise. Do example 3. Hint, because this is a little more complicated. So instead of taking the limit over n, extend to a limit over real numbers, so over x element of r, and use L'Hopital. Because to use L'Hopital, you take derivatives, so you have to be talking about a limit over the real numbers.